A request to do reactions of alcohols with PBr3, phosphorus tribromide. I've done this reaction with the third example, the third time PBr3 is used. The first two times made this. I don't want you to show me the same thing 3 times is why. Thionyl chloride and pyridine are these, and then toluene, sulfonyl chloride and pyridine are these. The easiest of the 2 mechanisms is the first, 3 mechanisms is the first one. It involves no less than 2 SN2 reactions consecutively. And phosphorus has a leaving group on it. So it's the one that gets attacked by the poor nucleophile. I don't like the way that started. 1, it didn't look like a lone pair. 2, it needs to look bigger. There we go. 2 consecutive SN2s. Backside attack on the phosphorus and the leaving group leaves. Generates 1 intermediate that looks like this. It's got an OH with a P attached. But most importantly, an oxonium is a very good leaving group. It's going to leave as a neutral species. And this is backside attack number 2. You guys know what happens to an R stereocenter in a backside attack. It needs to become an S stereocenter. That's the only product. And it's a very simple mechanism. This would only be 4 points. This one's worth 8, I think. And the next one's worth 6. I'm going to do it like we did during lecture, because the mechanisms are identical until the last step of this middle one, which is this one, which has an extra step. And this one doesn't have the extra step, because this one involves an exceptional leaving group, and this one doesn't ever have one. It has a good leaving group at the end, but not exceptional. Lone pair on O. Both mechanisms attacks the atom that's called sulfur. And this time you do not break off a halogen because there's pi bonds present. A very wandering arrow there. Pi bonds always break before sigma. They're weaker. I hope you see that they're identical mechanisms so far. Yeah, let's try to even have them above each other exactly. I don't like this arrow, it's just too big. Wild. I'm just going to make it a little smaller. Then go from the top. There. Same arrow, isn't it? Attack sulfur. And the result is 2 species up here. This species got an O with an H, and the sulfur has an O minus and 2 Cl. This one has the O with the A. Oh, I'm going to lose a half point unless I put my cation on my O. It's it's an oxonium, sorry. And same deal here. An O with an H and a plus charge. And I don't want to be drawing this ring anymore, so it doesn't change. It's part of TS. We got that R. So it has sulfur with an O minus, like above. I need a lone pair on that. And on this, it's got a double bond to O on the bottom. Still has a Cl. And has my R. There we go. Pyridine's job is to grab strong acids protons. It's a weak base. It couldn't grab the H from an alcohol because the acidity is too poor for an alcohol. but it definitely can grab the H from an oxonium, pKa -3. And there you have it. Exact same chemistry for both mechanisms up to this point, and they will be exactly the same in the next step as well. We got this is attached to an O wedge and neutralized, yeah. And O, move that over a little if I can. Line it up a little better with the one, with the one below it or above it. There, they're lined up. To a sulfur that has an O minus, need a lone pair, and a double bond O, and a Cl, and an R. And it's time for an elimination to get your pi bond on sulfur back. Resonate down, kick off Cl minus. Resonate down, kick off, well, that's a bad arrow. Resonate down, come on. I had my hand on the screen. Resonate down, kick off Cl minus. So here's where the exactness ends. They're exactly the same up until this point. This one is not finished yet. And the other one is. Done. It's got the OTS, which is basically looks like this, but there's an O here. This is the TS right here, up to the sulfur. TsCl. So that's an OTS. Stereocenter was never touched on this carbon. Never touched it once. And until now, we haven't touched this one either. You did make a Cl minus here. And you did make a Cl minus here. Cl minus is not a strong nucleophile. It will not react with a secondary Rx. That's what this is. That's a leaving group right there. It will attack this secondary carbon because it has a way of becoming a gas. That's not an excellent leaving group. It's an exceptional leaving group. Hit the carbon. Backside. SOO is becoming a gas after Cl minus leaves. And that gives the second product. You did a backside attack on an R stereocenter. You better pick the product that has an S stereocenter. And that's that. Has to be the end. I dropped my pen. Yeah, it's like mic drop. Yeah, and it's the end of class, so it's perfect. Kanye, eat your heart out. Okay, there we go. Sorry about that.